Good morning, everyone. Good morning, Palak. Good morning, Jeremy. Good morning, Kinnari. Good morning. Good morning, Divya. Good morning, Raj. Good morning, Jai. Good morning, Himadri. Good morning, Harsh. Good morning, Heli. Good morning, Priyansh. Hello, Vandan. Okay, good morning to all of you. Now there are so many. Hello, Kathan. Hello. Okay, let's get started now. Right? Many of you are here, and it's time anyways. So yesterday you were given this one question in homework, right? I hope you have done it. We're going to quickly discuss the answers. Yes, good morning everyone who have just joined. Good morning. Okay. Uh, so these are the important points that I sent you yesterday, right? We discussed a little bit about slope of line again, all right? Okay, positive slope, zero slope for horizontal line and negative slope, all right? And these two sentences about direction of velocity and direction of acceleration, right? That the object moves in the direction of velocity and that has nothing to do with direction of acceleration. Good morning, Preet. Okay, and where's your homework question here? Right. So I'm very quickly going to write the answers to this. Okay, we will not take a lot of time with this one, right? Because we have done such things earlier, right? I expect that we'll be able to get done with it very quickly. Okay. All right. So this is a xt graph given to us, and we have to solve these following questions, right? Okay, the first one, when does the particle come to rest? Okay, the particle comes to rest when its velocity, rest again means not moving, that is the velocity is zero, right? So that happens between 2 and 3 seconds, yes, right? It is at rest between 2 to 3 seconds, right? So the answer to this question is it is at rest from 2 seconds to 3 seconds. All right, that's the answer of the first question, right? I will not go into a lot of details. We have already seen that if you want to find velocity from an xt graph, this is xt graph, right? From xt graph you can find velocity by slope of tangent, right? So we have talked about all that, so I don't think it's worth repeating. Okay, all right, second one, when does the particle cross origin? All right, on this one I would like to have your answers. Can you tell me, can you answer this? Can you answer this in the chat box, please? When does the particle cross origin? Okay, we are starting to get answers. All right. Yes, many of you are getting it right. It is that the particle crosses origin two times. You can see one is at this point, right, where x is 0, right? This is x equal to 0. So over here. And the second one is over here. So the answer of this question is at t equal to 1 second and t equal to 4 seconds. All right. Okay. So that's what we have. Now, third question. Right, third question. Can you answer this? Come on, I'm waiting for your answers. Third question. Okay, many of you are saying 4-second particles velocity is negative, but only at 4 seconds, nowhere else. Only at 4 seconds, nowhere else. Not at any other time. All right, we're getting many answers. We please contact me personally for that doubt. All right. Okay. Now, everyone, see, I want all of you to have your brains extremely active. All right, it's very important. Okay, don't take anything casually. See, this is velocity negative. How do you find velocity from this graph? Can you tell me that? How do you find velocity from this graph? Which graph is it? How do you find velocity from this graph, everyone? Yes, drawing a tangent, right? And we should find the slope of tangent. That's right. Okay, yes, slope of tangent. So it's quite simple that slope of tangent is velocity in this situation, right? Slope of tangent is velocity, and we want velocity to be negative, right? So we want this to be negative. So where do you think you should draw a tangent? Where should you draw a tangent so that slope of tangent is negative? Where should you draw a tangent so that slope of tangent is negative? Come on. Okay, Neil, that's right. No, Tapan. No, Nandini. No, 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 no. We are getting lots of wrong answers. Yes, 3 to 4. Okay, everyone, have a look. Yes, Hard, correct answer. Well done. No, Ayush. No, Pinak. Okay, Vishwa, it is half the answer. Nemi, it's not the perfect answer. No, 3 seconds is not the answer. All right. Okay. I don't want any more answers. All right. Everyone stop and listen to what I'm saying carefully and look at the screen carefully. All right. Let's draw tangents. Suppose I would draw a tangent somewhere here. It would look like this. Okay, positive slope. Over here, positive slope. Over here, positive slope. Over here, zero slope. Over here, zero slope. Over here, you see, there's a negative slope, right? So I think you realize that if we draw a tangent on right side of this line, everywhere the slope of tangent is negative. So the correct answer to this question is 3 seconds to 5 seconds. All right, anywhere from 3 seconds to 5 seconds, the slope of tangent is negative, right? Okay, clear? And everyone, see, you'll have to draw. Okay, Kavya, you can contact me personally. All right. Everyone, you'll have to draw diagrams and draw such things. એમને નહીં આવડી જાય, ખાલી આમ જોઈને tangent. Okay, answer. એવી રીતે ન હોય. Right? Physics is disgustingly difficult. Right? Okay. Don't be casual. You have to give all your effort. જરૂર પડે તો એક એક ક્વેશ્ચન પછી થિયરી વાંચી લેવાની, right? Okay, so here you can see that the slope of tangent is negative in all these portions. Actually, you know, you can just say that wherever this graph is going down, wherever this graph is going down, right, this is going down, agreed? At that point or in those portions, velocity will be negative, and wherever it goes up like this, right, there the velocity is positive, right? Okay, that's like a cheating or shortcut, right? It is correct though, right? I'm saying it is cheating, but it is correct. There's nothing wrong with that logic. Yes, you have written 1 to 4 to 5 is not complete, right? 3 to 5 is the correct answer. Okay, find the path length of the particle in first 5 seconds. This I'm not going to ask you, I will just write it immediately. It is 30 meter. All right, 30 meter, 15 up and 15 down, 30. All right, not 35, Sahil, only 30 meter. All right, how many of you got that 30 meter? Can you say yes or no? How many of you got that? Okay, very good. Those who didn't get it, you can contact me personally, no problem. All right, તમને phone number એના માટે જ આપ્યું છે, right? But everyone will please send a WhatsApp message first and then we'll proceed. All right, okay. Now so that's it for these questions. Let's go to the next thing. Okay, more graphs to picho જ નહીં છોડે, right? Graphs are there in every chapter, in every topic, almost. Okay, now so we will continue with xt graph, right? But this time we are going to talk about how to find direction of acceleration from xt graph, right? Direction means sign also, right? Because I think you do remember that whenever we write a vector, the sign is indicating direction. All right, so how to find sign or direction of acceleration from xt graph, that's what this topic is about. Listen to this very, very carefully. Okay, first of all, let's take a typical xt graph. All right, okay, and let's say that graph is maybe a straight line like this. Okay, this is xt graph, position time graph. Okay, now I think that even if I would hide this portion, right? See, I had the complete line, right? Even if I would hide this portion, the slope is the same, right? Correct? I think you do realize that whether I take this part of the line or I take this part of the line or I take this part of the line, the slope is same, correct? That is because this is a line and line is always straight. Okay, this is happening because this is straight or it's a line. That's why slope here and the slope here and the slope here is all same, right? But the same would not happen if this graph was not straight, that is, it was not a line. Let's take an example. Suppose instead of this, the graph would have been curved like this. Okay, I'm going to draw it now. Okay, so this is a curved xt graph. All right, okay, this is a curved xt graph. Now here you can see that if you only look at this portion, it's less slope, right? Here tangent draw karo to. If you draw tangent here, the tangent would look like this, right? But if you look at another portion of the graph, maybe over here, right, this one, and if you draw a tangent over there, right? So which tangent has more slope, first or second? Which tangent has more slope? Very good, very good. So of course you can clearly see that the slope is changing, right? Slope has changed, right? But I'm sure you remember that from xt graph, if you find slope of tangent, that's velocity. So here what we have is, because slope is same everywhere, so whatever is the velocity here is the same as velocity here is the same velocity here, correct? But over here, this is v1 velocity, it's going to be less than the v2 velocity, right? Agreed? So what I'm saying is, that here the velocity is same everywhere, right? At every time. Maybe at 1 second it's v, at 2 seconds it's v, at 3 seconds it's v, it's at 4 seconds also it is v, like that. So this kind of straight line xt graph, means velocity is constant. If velocity is constant, what is acceleration? If velocity is constant, what is acceleration? Zero, right? જોયું તમને ક્વેશ્ચન સમથા નથી આપતો, આ બધું કામનું છે જો મારે અત્યારે ન ભણવું પડે, right? So velocity is constant, so acceleration is zero. So in short, if xt graph is curved, velocity will change, right? Velocity will be changing, correct? But if xt graph is flat or straight, right? If xt graph is straight line, then the velocity is not changing, it is constant, and then acceleration is zero. So basically what this means is that, write this sentence: curvature of xt graph indicates sign or direction, as you want to call it, of acceleration, right? Okay, curvature of xt graph indicates sign or direction of acceleration. Now along with this, there are two important points that you should remember, right? If the xt graph, okay, if the xt graph is like this, or a part of it, if it's like a bowl, right? I'm sure you understand that. If it's like a bowl, what should I repeat, Chintan? This is it. Okay, curvature means how it is curved, right? Curvature means how the graph is curved, right? So that how the graph is curved indicates sign or direction of acceleration. That's what I'm saying, right? What indicates velocity? Slope of xt graph, right? Again, velocity is indicated or is equal to slope of xt graph. But acceleration is not slope of xt graph. Acceleration is indicated by curvature, right? So how exactly? That's what we are writing here. If the xt graph shape is like a bowl, then that would indicate that the acceleration is negative, right? But on the other hand, oh no, sorry. Okay, I made a mistake. I'm so sorry. I just wrote it opposite. Okay, this, if xt graph is like a ball, acceleration is greater than zero, and if xt graph is like a bump, okay, if this kind of curve graph is there, then that would indicate acceleration is less than zero, right? Actually, there's one easy trick to remember. Bump means you'll have to decrease the speed, isn't it? Right? So you can then remember that acceleration is less than zero for a bump. All right. Okay. I'll of course explain the logic behind this. All right. But like I mentioned, this is extremely important for you to remember. All right. આ યાદ રહેવું જોઈએ. Got it? Okay. Now we'll go to why it is like this. Thank you, Rohan. Now I'll tell you why it is like this. What's the reason or what's the logic behind this? All right. Okay. Have you written this? Have you written it, everyone? Shall I change the page? Okay. Okay, hurry up, please. I'll just give you 30 seconds more. All right. Param, I have not understood what you're trying to say. So 2 acceleration is in negative. What does that mean? What is meaning of 2 acceleration? Param, if you can write it in some different way, it would be easier for me to understand. Okay. Yes. Second is like bump. Yes. So that will indicate negative acceleration. Kavya, you could remember it like that. Okay, but that's of course that's like a simple way or trick to remember. Now I'm going to tell you the logic. Okay, why is that sentence correct, or what does I mean? How do we actually get that what we wrote? Okay, so let's start with that. Suppose we first of all talk about. Suppose we will talk about a case where xt graph is like uh, a bowl. Okay, let's start with that. Let's say like this. Now see, you'll have to be extremely careful as I speak, as I draw. You'll have to listen and you'll have to look at it carefully. So let's say that this is time 1 second. Suppose here is time 2 second. Here is time 3 second, 4 and 5. I think that's enough. All right. And then if we would draw tangent, right? Okay, I've drawn a tangent. All right. Okay. Okay, so this is the first tangent, right? Let's draw a second tangent here. All right, something went wrong here. I'll just do it again. Let's draw a third tangent here, right? Let's draw a fourth here. And finally, let's draw a fifth here. So look at the tangent 1, 2, 3, 4, and 5, right? Okay, do you understand that slope of first tangent, I'm just writing that as slope 1, is negative, right? Slope 2 is also negative. Slope 3 is 0, right? This is negative, this is negative. Slope 4 is positive, and slope 5 is even more positive, right? Okay, so I hope you can realize that gradually as time is passing, time was 1 second, then 2, 3, 4, and 5, right? As time passes, the slope of tangent is increasing. I repeat, slope of tangent is increasing. First it was negative, then it becomes 0, and then it becomes positive. You know, something like, suppose first it was -3, then gradually becomes -2, then -1 and 0, and then +1 and +2. So you can see that these are numbers in increasing order, correct? Okay, so I'm writing a sentence. Tell me yes or no whether you understand that sentence. Here, slope of tangent, but slope of tangent obviously means velocity, right, is increasing with time. Inc means increasing. Okay, increasing with time. Let me just write it here, increasing. Do you understand this sentence? First it was negative, then gradually it becomes 0, then it becomes positive, so it's increasing, right? Okay, now such, this would actually mean, right, if the velocity v is velocity, slope of tangent, right? So velocity is increasing with time, and that means acceleration is greater than 0, right? Okay, whenever any quantity increases with time, then its rate of change or its differentiation is positive, right? Okay, I think you all understand that, right? If some quantity is increasing with time, right, then its change is always going to be positive, right? Because change is always final minus initial, right? Oh, sorry. Okay, so because of that, what we have is that the acceleration is greater than 0 and velocity is increasing. All right, so this is indicated by which shape of xt graph? By a bowl shape xt graph. All right, so this is the first sentence that we wrote on the previous page. All right, clear? Now we will talk about the second case, right? Okay, bump shape. Let's see what happens over there. Okay, all right, so this is the xt graph, right? Okay, and now if I would draw a few tangents, all right, let's say at 1 second, at 2 second, 3 and 4. So you can see at 1 second the tangent is like this, at 2 seconds the tangent is like this, right? Over here somewhere it's horizontal, so zero slope. Over here it's okay, over here it's like this, right? And over here it's like this, correct? So look at tangent 1 2 3 4 5. Which tangent has maximum slope? Yes. Okay, see, some of you are still using intuition. Wait a minute, some of you said that 5 has maximum slope. Actually that's exact opposite. 5 does not have maximum slope, 5 has the minimum slope. Because listen to this, I agree that 5 is very steep, right? You understand what is steep, but look at the shape, look at how it is, it's like this. Such lines have negative slope, correct? Right, such lines will have negative slope. So that would mean this line 5, its slope would be something like minus 10. All right, its slope would be something like minus 10. On the other hand, this line 1, tangent 1 is like this, so its slope is positive, right? And I agree it's not very steep, so its slope might be like 6. Which is more, 6 or minus 10? Which is more, 6 is more or minus 10 is more? Obviously a positive number will be bigger than a negative number, correct, in every case. So that is what is happening here, right? So uh, tangent 1 has maximum slope, then little bit less for tangent 2, then little bit less for 3. I mean, it's here it's nearly 0, right? And then for 4 it is negative, and for 5 also it is even more negative, right? So you can see here the slope is going from positive to 0 to negative, correct? So here we can say that first at 1 second velocity was positive, right? At 1 second velocity was positive, at 2 seconds also it was positive, but then gradually at 3 seconds it becomes 0, right, roughly speaking, and at 4 seconds it becomes negative, right? So here you can see that velocity is decreasing, right? Downward arrow means I'm saying it is decreasing, right? Okay, what should I repeat? What should I repeat, Sahil? You tell me that, please. I'm saying that here in the first case, this tangent has slope maybe 6, right? Then the second tangent is less steep, so it has a little bit less slope, so it would be maybe 3. And then third one has 0. Then fourth one will have something like minus 2. and then fifth one has maybe minus 10. So you can see that this is velocity, isn't it? Slope of tangent is velocity in xt graph, right? So that's why I just asked you which number is bigger. 6 is bigger or minus 10? I gave you these values. These are examples, don't forget, right? I've set these numbers on my own, right? Okay. Yes, Dhruvi. Yes, Preet. Looks like you have question. Can you please type it? Okay. So I was saying that the velocity is decreasing. All right. Okay, I was saying that the velocity is decreasing in this case, right? And because if something is decreasing, then the change will be negative, correct? Right? Okay, then the change will be negative, right? I think you all realize that if suppose in one test, in first test your marks are 45 out of 50, but in second test your marks are, let's say, 30, then the change is final minus initial, second minus first, right? So how much is the change? Minus 15. Now this has happened because your marks have decreased, for example. All right. Okay, so again, decreasing thing would have a negative change, and that's why when v is decreasing, then a, which is dv by dt, this will also be negative, right? And so that's why we say that here this indicates a less than 0. So finally, to write it all again, whenever we have a bump shaped graph, xt graph, okay, bump shape xt graph like this, then acceleration is less than 0, and that means velocity is decreasing, right? Velocity is decreasing. I'm not even talking about speed over here, people. Okay, velocity and speed are different, right? I'm sure you all remember that. Okay, see, one thing that you need to understand is that it is also possible that graph is only a part of the bump or part of bowl. For example, only this much. Then also it means negative acceleration only, all right? So it's not necessary that it has to make a complete nice bump or a complete nice bowl shape, right? What if it's only this? Still, you can say this would indicate that acceleration is greater than 0, right? Okay, so that's what I'm saying. Even a part would do. Both graph. અરે રાહુલ તું હમણાં જો હું તમને ક્વેશ્ચન આપું, right? Yes, Priyansh. Actually, if you draw a graph, right? If you draw a graph, it can only be only 3 types. Listen to this. Now I'm going to introduce a little bit of mathematical language because I'm confident you will understand because you have asked me these questions, right? So it is as follows. There are only 3 possibilities for a graph, right? There are only 3 possibilities for a part of graph, right? Which 3 possibilities? First, it's straight. That is, it's a line. Okay, every straight thing is a line. Don't forget that. Okay, so it might be a line like this. All right, maybe going up, maybe going down. That's different. It's straight. No curve. I think you understand when I write no curve, right? Second is it can be opening or curving upwards. What do I mean? This is a bowl, right? This kind of part or graph is a bowl. Think about it. See it curves upwards, correct? Agreed? જો કાં તો straight હોય કાં તો curve થાય. તો curve થાય તો બે possibility. Either it will curve up or it will curve down. Okay, so this is the next one, opening or curving downwards, right? So that would be like a bump. Have a look at this, right? You can see this graph is curving up and this graph is curving down. રાઈટ. એટલે ત્રણેય એકમાં ડ્રો કરું તો આવું કંઈક થાય, ફ્લેટ, curving down, curving up, right? So this is number 1, this is number 2, and this is number 3, right? I hope you have understood what I'm drawing. Wave, Sahil, all that is combination of all this. Otherwise there are only 3 parts or 3 types. You can draw any graph by using these 3 together, right? હવે એ શીખવાનું છે. Let's start. So straight line xt graph means no acceleration, all right? Ball shape means acceleration greater than 0, and bump shape means acceleration less than 0. Let's practice question એટલે બધું આવડી જશે. ચલો, let's go to the next. So now I'm going to give you xt graph, all right? Now I'm going to give you xt graph, and I will ask you many questions. Let's start. So suppose this is that xt graph, all right? ઓકે, પૂછતા હતા ને કે આવું જ હોય, બીજું કઈ ન હોય. હવે લો, right? So this is a complicated shape xt graph, right? Okay, let me just change things a little bit also so that we can have it more interesting, roller coaster like ride. Okay. All right. So here this part is a straight line. અરે આને વેવ નો કહેવાય સાહિબ. વેવ આખી અલગ વસ્તુ છે. Okay, this is not a wave. All right. Now I'm going to ask you a few questions here. All right, be ready. So I'm marking several points, A, B, C, D, let's say E, all right, and maybe F over here. Okay, so now, so we have 6 points over here, right? What we have to do is we have to decide upon the direction. So this is all about deciding direction of, direction means sign, again don't forget that, sign of velocity and acceleration. All right, so everyone make a little table now, come on, make a table. Soothe you, Priyansh, what's your question? This is point, and this is V, this is A. Now we are just going to write plus minus, okay, like that. It's not a parabola, Ananya. Not parabola. Parabola is quite different, right? Okay, let's start. So at the point A, over here, I want to find direction of velocity. How do we find velocity from which graph? How do we find velocity in this graph? How do we find? Yes, slope of tangent. Princey, if you have a question, you could. Okay. Correct. So slope of tangent, and draw a tangent here, you will realize what we have. If you draw a tangent over here, the tangent slope is positive or negative? What do you say? Positive or negative? Velocity, positive or negative? Very good, very good, very good. V is negative. Okay, done. Chalo, ek puru. Minus means negative. All right. Now we go to A, acceleration. All right. Okay, acceleration, everyone, what do you think? Acceleration. No problem, time lagse. Okay, let's see, let's analyze this carefully, everyone. Now I don't want your answers. Okay, enough of answers. No answers anymore. People, stop. Okay, thank you. Listen to what I'm saying very carefully. Okay, I will just draw the graph again to make it neat, right? So this is where this point A was, right? So now at this point, do you realize that where the point A is, right, the graph is already like a ball, isn't it? Yes or no? Do you agree? I'm saying that near A or around that point A, the graph is like a ball. Yes or no? Okay, So bowl shape xt graph. Bowl shape xt graph means what? What acceleration? Bowl shape xt graph means which acceleration? Very good. Positive acceleration. Well done. It is very unintuitive, isn't it? એવું લાગે જ ને કે તમે જે વિચારો ને કંઈક બીજું જ નીકળે, right? So many of you said acceleration is negative, but that's not correct. Here the acceleration is positive. That's why I always say this is, whenever you give a physics answer, you think about reason 2 or 3 times. Without reason, don't give an answer, right? Most likely it will be wrong. Nature is hiding its secrets. Let me tell you that. Okay, nature is hiding its secrets. Okay, so in even when you look around yourself, nature is fooling you so many times. Okay, and that's why we have to learn and understand science, so that we can uh, reveal its secrets. All right, let's go to point B now. Okay, I don't want any abrupt answer. First of all, velocity at B. It will be good if you draw this diagram in your notebook. Kavya, do you have a question? Can you please write it if you have a question? What is the velocity at B? What is the velocity at B? Okay, no problem, Kavya. That's right. Most of you are getting it correct. Actually, very good. Well done. No, Vasu, constant is not correct. Constant is not a value. B is not equal to 0. Velocity at B is equal to 0, right? So don't say B is equal to 0. Okay, so yes, that's right. Many of you got it correct. The answer is that here there is zero velocity, right? Zero velocity. Not positive, not negative. Ekai baju nahi. Okay. How do we say it in words? V equal to 0. How do you say it in words? In English language? The maths you. How do you say it in words? In English language? Come on. What do you say? V equal to 0 means? No. તમે ઇંગ્લિશ લેંગ્વેજ યુઝ કરો. વેલોસિટી ઇઝ કોન્સ્ટન્ટ. આવું તમે 8th સ્ટાન્ડર્ડ વાળાને કહેશો તો તમને એમ કહેશે આ કઈ લેંગ્વેજ બોલે? ચાઇનીઝ? This means object is at rest. બરાબર ને? We say that object is at rest, or we say that object is stationary at that time. Stationary does not mean stationary shop. Stationary means not moving, right? Only at that time. All right, here at this time, whatever time that is, suppose 2 seconds. So then at 2 seconds, the object is, maybe you could say, tired, and now it's waiting over there for a small time, right? થાક ખાઈ લીધો જરાક, for a very small time, and then it starts to move again. All right, એવું થાય ને? Think of it. Suppose this is a slope, right? And on it you roll a ball up. What will happen? The ball will roll up, it will become slow. At some point of time, it will just stop and then start to come back, correct? So what it will do is, as it goes up, it will slow down, right? Okay, at some point of time, it will just stop for a small fraction of second, right? There its velocity will become 0, and then once again it will start moving down, right? Then it will start moving down, correct? This is what happens, right? Yes, object is at rest when velocity is 0, right? Okay, acceleration, everyone. Acceleration at B. Acceleration at B, people. What do you think? Positive, negative, 0? Acceleration at B. पुरानी आदतें जल्दी जाती नहीं. Come on, people. Okay. Many of you again made the same mistake. Many of you are saying acceleration is zero. Why? Why is acceleration zero? Because velocity is zero. Eh? People, follow the procedure. What have I taught you? This is which graph? XT graph. Okay, I don't want answers anymore. Okay. That's wrong. That's wrong. Everyone. Okay. First of all, I'll answer Param and Har, and their sentence is very important. Listen to this carefully. Rest means velocity is zero, acceleration may be anything. Let me be very clear. Rest has nothing to do with acceleration. Okay, rest has no relation with acceleration. Okay, rest has no relation with acceleration. Even if object is stationary at that point of time, again object is stationary at that point of time, or object is at rest, it means only v is zero. And what about a? You cannot know, it can be anything. Again, everyone, this is very important, make sure you write it. Okay, if you want to write it in words, you can write it. Rest means velocity is zero and acceleration has no relation with this. Okay, that means acceleration can be anything. Acceleration can be anything, right? I'll give you an example of that. You know, when you are in a vehicle, let's say this is your vehicle parked. Okay, let's say this is a vehicle and it is parked over here, right? The moment someone or the driver presses the accelerator, okay, the moment the driver presses the accelerator, at that very moment this vehicle will have some acceleration, maybe 5 meter per second square. Okay, right? But at that time, when the driver has just pressed the accelerator, okay, at that time the velocity will still be zero. Gradually the velocity will increase. So even at that time you can say that when the driver just presses the accelerator, the vehicle is at rest. Okay, but immediately after that, okay, very soon, because of the acceleration, the velocity will change. It will not remain zero, it will change. So you can say that when the driver presses the accelerator, vehicle is at rest. But after some time, okay, after some time, some means how much small, even infinitesimal time, after a little bit of time, the velocity will increase and it might become 0.001. Gradually it will increase, and then you will feel that okay, now the vehicle has started moving. Everyone, so rest only means velocity is equal to zero. It has no connection with acceleration. All right, acceleration may be anything, but velocity is zero, that's called rest. Okay, come back to this question. People, ઇન્ટ્યુશન છે ને કચરામાં નાખી દેવાનું, રાઈટ? ઇન્ટ્યુશન મીન્સ તમને આમ અંદરથી લાગે ને, હા મને એવું લાગે છે અંદરથી આનો આન્સર તો આ જ આવશે, એ છે ને ડસ્ટબિનમાં ફેંકીને જવાનું ફિઝિક્સના ક્લાસમાં. ઓકે, ઇટ વિલ નોટ હેલ્પ. ઓલરાઈટ, લાઈક આઈ હેવ ઓલવેઝ સેડ, વોટ એવર ઇઝ યોર ગટ ફિલિંગ, તમને જે અંદરથી લાગતો છે ને હા મને તો આવું લાગે આમાં આમ જ આવશે, એ નહીં જ આવે. દેટ ઇઝ કોલ્ડ ફિઝિક્સ, રાઈટ? એટલે જ તો હું તમને કહું છું કદમ કદમ પે ખતરા, બી વેરી કેરફુલ. ઓકે, હિયર એટ બી ક્લિયરલી acceleration is greater than zero. Why? Ball shape, easy peasy, isn't it? Yes or no? Did you understand? Yes or no? એનું લોજિક મેં સમજાયું હતું. What is that? On this side here, the velocity is negative, but on this side, the velocity is positive. So from negative, the velocity has become positive. So it means acceleration should be positive, right? Because it has changed that way. Okay. So that's done. So at B, the acceleration is positive. Let's write it over here. હજી તો ઘણું શીખવાનું છે. Don't get frustrated. Don't give up. Okay, let's go to C now. C, velocity at C. Velocity at C. People, velocity at C. Yes, positive. That's right. Because velocity is given by slope of tangent, right? And here if you draw a tangent, I last time explained કરું છું, હવે તો સીધો answer જ આવશે, right? If you draw tangent like this, you can see the tangent slope is positive. Okay. Acceleration at C. Come on, people. Acceleration at C. I've started to get some right answers. I'm happy about that. Okay. Okay. Very good. Most of the answers that I've got are correct. And the correct answer is that the acceleration is negative, right? Have a look. Have a look at this graph very carefully. Look at this part around C. જો અહીંયા સુધી છે ને એ bump જેવું છે. Do you agree? In this part it's like a bump, correct? Sorry, ball. Over here it's like a ball, right? But now from here it's like a bump. Agreed? This is like a bump over here, correct? Right? I hope those who got it wrong have understood this reason. All right? So that's why the acceleration is negative. Okay. Now I want both answers of D together from you. Okay? Say it in one message only. Be alag nahi karta. Please put everything in one message. Both answers for D. Velocity and acceleration. Both answers for D. Okay, we have got 5 correct answers. I'm actually very happy about that. Well done, people. 6, 7, 8, 9. All right, very good. No, Dhruv. Okay, very good. We're getting lots of correct answers. Well done, people. No, Ayushi. No, Dharmi, that's not right. Okay, yes, the correct answer is... Yes, Vasu? The correct answer is that the velocity is 0 and acceleration is negative. All right, everyone. Velocity 0 and acceleration negative. All right. So that is it. Now I want all of you to draw this graph in your notebook, and E and F are for homework. All right. E and F are for homework. Remember, F, straight line. Here the graph is a straight line. Okay. Don't forget to write this. Hard, what's negative? What are you asking about? Fine. At F. But what is negative at F? What are you asking about? Acceleration or velocity? We will talk about the answers tomorrow. Yeah, velocity is negative. That's right. Okay. Now, okay, let's continue. Types of XT graph. Okay, types of XT graph means there are different possibilities for XT graph, right? Let's draw these so that you will be able to solve questions faster. So this is typical XT graph, right? And let's say that the XT graph is a horizontal line. Okay, let's say that this XT graph is a horizontal line. See, what this means as follows. When time is 1 second, for example, this is position, let's say 3 meter. Okay, this is again example, all right? Okay, don't forget that. Then when time is 2 seconds, then also the position is 3 seconds. When time is 3 seconds, so every time the position is 3 seconds. What does that mean? It means the object is not moving at all, correct? Right? It is not moving at all. Agreed? No, not uniform motion, Ananya. This means that the velocity is equal to 0, right? Always, right? It means velocity is constant and it is also equal to 0, right? It means object is not moving at all. Or you could say there is no motion, right? Okay. All right. See, in this case, because velocity is constant, what will be acceleration? Yes. So this is that case where v is always 0 and a is also always 0, right? But remember, this is not true in every other case, right? Here it is only true because there is no motion, right? Otherwise, always both of these are not equal to 0, right? So they will be different, right? Again, because velocity is constant, that's why acceleration is 0, not because of this. All right. Okay. And you can also see that this graph is not curved. All right. So that's why acceleration is 0. So this is the first graph. Let's talk about second. We will not be able to finish all, right? So we will just finish whatever we can, maybe 2 or 3. So let's say this is again XT graph, right? Now suppose the graph is a straight line. See, this is also a straight line. Earlier one was a straight line, but it was horizontal. All right. So what can you say here? What will you say about velocity? Is velocity positive, negative? Is velocity positive or negative? Come on. Yes, very good. Correct. Velocity is positive, right? Many of you said velocity is positive. That's right. चलो હવે एक step આગળ. Can you tell me reason? How do you know that the velocity is positive? How do you know that the velocity is positive? કોણે કીધું તમને? મેં તો કીધું નથી. Right? What is the reason? How did you come to know? Ami, I'm not asking about increasing. Everyone, I would like that you do not use pronouns. Don't say it is going up. Wrong, Chintan. Slope of graph is not going up. Yes, Dharmi, that's right. Wrong, Saurabh. Okay, so we are having some confusions or misconceptions, and that is normal. Okay, don't worry. Here is the perfect reason. Listen to this. Some of you gave the perfect reason, okay, but there were still many answers that were not perfect, so I have to tell you. Look at this. This is XT graph, right? If you will try to find slope anywhere, over here or over here or over here. You see the slope is same, right? Again, let me repeat what I said before a while as well. This is a straight graph, it's not curved, right? I hope you remember the three possibilities, right? Straight, oh sorry, straight like this, curved or curved, right? There are three possibilities, correct? This is a straight graph. Agreed? Straight graph means the slope is same everywhere. And because the slope is same everywhere, right? Okay, because the slope is same everywhere and the slope is positive, right? I'm sure you understand that by looking at this line, you can clearly say that the slope is positive, right? Everywhere. That means here the velocity is positive. But because the slope remains same, the velocity is also constant. So here the velocity is positive and here the velocity is constant. Who understood both the reasons? Can you please say yes or no? Positive we know from slope, right? That slope is positive. But constant we know from this or this, right? Both reasons are correct. You can't say slope is going upwards, right everyone? Remember, you cannot say slope is going upwards. Slope is not an object. If you climb up a hill, will slope climb with you? Is slope an animal? Will slope come up with, right? Slope is not an animal. Slope is not even an object, right? Slope is just a number. Yes, positive slope. That's correct. You could say the slope is positive, right? All right. Okay. So the important thing here is to remember this. Okay, I'll just take one moment. Okay, don't worry, we'll not be very late. It is that because this graph is a straight line, okay, because this graph is a straight line, right? That's why here we have velocity is constant, right? Because it's a straight line, velocity is constant. Because the line is going up on the right side or climbing up on the right side, or you could say slope of tangent is positive, so velocity is positive. Okay, what about acceleration? What about acceleration, people? Can you tell me what's the acceleration? I'm looking for, okay, very good. The acceleration is 0, right? Okay, and it is 0 everywhere, remember. So you could say that here acceleration is also constant and it is 0 everywhere, right? Okay, because the graph never curves. All right, so I think that's it. These are two. We will talk about more cases the next time. Okay, so goodbye everyone.